Imagine building a machine learning model that can predict house prices with impressive accuracy. You've trained it on a massive dataset, fine-tuning every parameter, and now it's remarkably accurate. But what good is a powerful model if it's stuck on your computer, inaccessible to others? This is where web deployment comes in, bridging the gap between your model and the world. Deploying your model on the web allows anyone with an internet connection to access and use it, regardless of their location. This opens up a world of possibilities, from building interactive web applications to providing real-time predictions through APIs. This essay serves as your comprehensive, step-by-step guide to deploying machine learning models on the web. We'll walk through the entire process, from choosing the right tools and platforms to making your model accessible to the world. Whether you're a beginner or have some experience, this guide will equip you with the knowledge and skills to share your machine learning creations with the world, making them available to anyone, anywhere. Before we dive into the specifics, let's outline the general steps involved in deploying a machine learning model on the web. First, you'll need to choose a web framework. This framework will provide the structure for building your web application. Next, you'll prepare your trained machine learning model for deployment. This typically involves saving the model in a format that can be easily loaded and used by your web application. Once your model is ready, you'll create an API, an application programming interface. An API acts as a bridge, allowing your web application to communicate with your model. Finally, you'll deploy your application to a cloud platform. This makes your model accessible to anyone with an internet connection. Selecting the right web framework is crucial for a smooth deployment process. Two popular choices are Flask and Django. Django is a powerful, full-featured framework, while Flask is known for its simplicity and flexibility. For beginners, Flask is often the better choice. It's easy to learn and set up, allowing you to focus on the core aspects of deployment without getting bogged down by complex configurations. Flask's minimalist approach makes it ideal for building APIs and simple web applications around your machine learning models. We'll be using Flask throughout this guide. Before we start building, let's set up Flask, a lightweight web framework for Python. You'll need Python installed on your system. Open your terminal or command prompt and type pip install Flask. This command will download and install Flask along with its necessary dependencies. This command installs Flask and its dependencies, ensuring you have everything you need to get started. Once installed, create a new folder for your project. This folder will contain all the files related to your web application. Inside the folder, create a file named app.py. This will be the main file for your Flask application. This file will hold the code for your Flask application, acting as the entry point for your web app. Now let's write some basic Flask code to test if everything is working. Start by importing Flask with from Flask import Flask. Then create an instance of the Flask class app =Flask, yap.root def hello. Return hello world. This function will run when you access the root URL of your web app. If == main app.run debug =true, save the file. The debug =true parameter will help you debug your application by providing detailed error messages. Now, open your terminal, navigate to your project folder, and run Flask run. This command will start a local development server. You should see a message saying running on http:/127.0.015,000/. This indicates that your server is up and running. Open this address in your web browser, and you'll see "Hello World" displayed on the screen. Congratulations, you've just created a simple Flask web application. This is your first step into the world of web development with Flask. Section 5. Preparing your model training and saving. Now let's prepare your machine learning model. We'll assume you've already trained a model using your preferred library, for example, scikit-learn, TensorFlow, or PyTorch. The next step is to save your trained model to a file. This allows you to load and reuse the model without retraining it every time. Python provides libraries like Pickle and JobLib for saving models. Pickle is a general-purpose serialization library, while JobLib is optimized for large NumPy arrays, which are common in machine learning. Here's how to save a model using Pickle Python import pickle hash. Assuming model is your trained model file name =model.bkl pickle dump model open file name wb. This code saves your model to a file named model.pl. You can later load this file to reuse your trained model. Section 6. Integrating with Flask, loading your model. With your Flask app set up and your model saved, it's time to connect the two. First, you'll need to load your saved model into your Flask application. Add the following code to your file. Python import pickle hash. Load the saved model =pickle load open model pklrb hash, rest of your Flask app code. This code loads your saved model from the model.kl file and assigns it to the variable model. Now your Flask app has access to your trained model. Remember to place the model.pkl file in the same directory as your app.py file. Section 7. Building the API opening doors to your model. Now let's create an API endpoint that will allow users to send data to your model and receive predictions. An API endpoint is a specific URL that handles communication between your web app and the outside world. Add the following code to your file to create an endpoint. Python from Flask import request eapp.route, predict, methods, post, def predict, hash code to handle predictions will go here pass. This code defines a new route /predict that only accepts post requests. Post requests are used to send data to the server. The predict function will handle incoming data and return predictions. Section 8. Handling input. Understanding user requests. When a user sends data to your API, Flask provides a way to access this data through the request object. Let's assume your model expects input data in JSON format. You can access the JSON data from the request body like this: aapp.route, predict, methods post, def predict. The request.getJSON function parses the incoming JSON data and returns a Python dictionary. You can then access the values of the dictionary using their corresponding keys. For example, if your JSON data looks like this, you can access the values like this: feature 1 equals sign data, feature 1, feature 2 equals sign data, feature 2. Section 9. Generating predictions. Putting your model to work. Now that you have the input data, you can use your loaded model to generate predictions. Assuming your model has a predict method, you can make predictions like this: oapp.route, predict, methods are post, def predict. This code first extracts the necessary features from the input data. Then, it uses the model's predict method to generate a prediction. Finally, it returns the prediction as a JSON response. The DORS at the end of prediction is used to extract the prediction value from the array returned by the model. Section 10. Local testing. Ensuring everything works. Before deploying, it's crucial to test your API locally to ensure everything is working correctly. You can use a tool like Postman to send test requests to your API. Download and install Postman. Once installed, open Postman and create a new request. Set the request type to post. Set the URL to http:/127.0.0. 15,000 Replace 5,000 with your Flask app's port if different. Go to the Body tab, select Raw, and choose JSON from the drop-down. In the request body, enter sample JSON data in the format expected by your API. Click Send. If everything is set up correctly, you should receive a response with the prediction from your model. Section 11. Cloud deployment. Sharing your model with the world. In this section, we will guide you through the process of making your model available to users across the globe. Now that your API is tested and ready, it's time to deploy it to the cloud. This step is crucial as it ensures that your model can be accessed by anyone, anywhere, at any time. Deploying your model to the cloud makes it accessible to anyone with an internet connection. This opens up a world of possibilities for your application. We'll be using Heroku for its simplicity and efficiency. First, sign up for Heroku if you haven't already. Create a free account on Heroku. Then, install the Heroku CLI, which is a command line interface that allows you to interact with Heroku from your terminal. This tool is essential for managing your Heroku apps. Next, create a requirements.txt file in your project folder. This file lists all the dependencies required for your app to run smoothly on Heroku. In your project folder, create a file named requirements.txt and add the following: Flask, which is a micro web framework for Python, scikit-learn hash, or your chosen ML library. Next, create a proc file. This file tells Heroku how to run your app. It's a simple text file that specifies the commands that Heroku should use to start your application. Create a file named procfile, no extension, and add web Gunicorn app. Now initialize a Git repository in your project folder. Use the following commands: git init, git add, to add all your files to the repository. Then commit your changes with git commit m initial commit. Create a Heroku app by logging in with Heroku login and then Heroku create. Finally, deploy your code with git push Heroku master. Once the deployment is complete, open your app with Heroku open. Congratulations, you have successfully deployed your machine learning model to the web. Your app is now live and accessible to users around the world. Your app is now live and accessible through the provided URL. Share this URL with your users and let them experience the power of your model.